Good morning, everyone. I'm excited to welcome you to today's session. Today, we're diving into energy-saving training in India. We'll explore how we can empower India's facility managers and energy engineers with practical strategies for sustainable operations. This presentation is brought to you by Elion Technologies and Consulting Private Limited. Over the next few minutes, we'll cover key concepts, best practices, and innovative approaches to energy efficiency. Let's get started and make this session both informative and inspiring. India's energy landscape, a critical moment. India stands at a pivotal juncture in its energy journey. As the world's third-largest energy consumer, our nation is experiencing an unprecedented surge in demand. This growth is driven by rapid industrialization, expanding urban areas, and overall economic expansion. The challenge we face is clear. How do we meet this surging demand while also transitioning to more sustainable practices? Industrial and commercial sectors are responsible for nearly 60% of India's total electricity consumption. That's a huge opportunity, because every kilowatt saved in your facilities directly contributes to our national energy security and helps achieve our environmental goals. And here's some good news. Energy efficiency improvements of 20 to 40% are achievable in most facilities, using existing technologies and smarter operational practices. So, when we look at the numbers, 8% annual energy demand growth, 60% consumption by industries and businesses, and the potential for up to 40% efficiency gains. It's clear that energy efficiency isn't just good for the environment. It's vital for our economic stability and future. This is a critical moment for us to act, to innovate, and to lead in building a sustainable energy future for India. Let's talk about why energy efficiency matters now and why it's a critical focus for us. First, cost reduction is a major benefit. You see, energy costs can account for anywhere from 30 to 50% of operational expenses in manufacturing facilities. By implementing efficiency measures, we can significantly cut down on these costs, sometimes saving between 10 to 30 lakhs annually for medium-sized operations. That's a substantial saving that directly impacts our bottom line. Next, there's the aspect of environmental responsibility. India has committed to reducing emissions intensity by 45% by 2030, and every sector, including ours, needs to contribute. Improving energy efficiency in our facilities isn't just good for the environment. It's a way to support national climate goals and demonstrate our commitment to sustainable development. Now, let's consider the competitive advantage. Operating efficiently doesn't just save money, it also boosts productivity, lowers maintenance costs, and improves the quality of our products. Plus, companies that prioritize sustainability tend to attract better talent and more customers who value responsible business practices. It's about positioning ourselves as leaders in our industry. Finally, regulatory compliance is a key point. The Bureau of Energy Efficiency requires energy audits and consumption reporting for designated consumers. If we take proactive steps to improve our energy efficiency, we can ensure compliance smoothly and avoid penalties. Overall, embracing energy efficiency is not just about saving costs. It's about aligning with our environmental responsibilities, gaining a competitive edge, and meeting regulatory demands. Welcome to Slide 4, where we highlight Elion Technologies as your trusted energy efficiency partner. For over 15 years, we've been leading the way in energy management solutions across India. Our team combines deep technical expertise with practical experience, working across a wide range of industries, from automotive manufacturing and IT parks to chemical plants and commercial complexes. Our approach is comprehensive. We start with detailed energy audits using advanced diagnostic tools to identify inefficiencies. Then, we develop customized efficiency roadmaps tailored to your operational priorities, ensuring solutions are aligned with your specific needs. We don't just design plans, we support implementation from start to finish, covering everything from design to commissioning. Once the system is up and running, we monitor performance continuously, making ongoing adjustments to optimize results. We also offer training programs to help your team sustain these improvements over time. Looking at our track record, we've successfully completed more than 500 energy efficiency projects, with our clients typically saving between 25 and 35% on energy costs. Our systems are ISO 50001 certified, and we've been recognized by the B with the National Energy Conservation Award. Finally, our presence spans across India, giving us regional expertise that helps us deliver tailored solutions wherever you are. All of these points emphasize our commitment to helping you manage energy better, reduce costs, and contribute to sustainability, core themes that run through our entire approach. Now, let's take a closer look at monitoring and verification, which is the final step in our training program overview. Here, the focus is on establishing clear KPIs, key performance indicators, that help us measure how well our energy-saving initiatives are performing. We'll discuss measurement protocols to ensure data accuracy and consistency, and reporting frameworks that keep everyone informed and accountable. But beyond just tracking, this phase emphasizes continuous improvement. It's about creating a feedback loop where we regularly review performance, identify areas for enhancement, and refine our strategies. This ongoing process is essential to sustain energy efficiency gains and optimize system performance over time. By mastering these monitoring and verification techniques, you'll be equipped to ensure that energy projects deliver consistent, measurable results and contribute to long-term sustainability goals. This step truly ties together everything we've discussed so far, reinforcing that effective energy management is an ongoing journey rather than a one-time effort. Welcome to Module 1, where we focus on energy assessment fundamentals. This module is really about building a strong foundation for systematic energy management. Think of it as the starting point for understanding how energy flows through your operations and identifying areas where improvements can be made. By establishing these fundamentals, you'll be better equipped to analyze your energy usage, pinpoint inefficiencies, and develop effective strategies for saving energy and reducing costs. This module connects directly to the overall theme of the presentation, which is about creating sustainable, efficient energy practices. Remember, a solid foundation in energy assessment is crucial because it sets the stage for all the subsequent steps in managing energy effectively. So, let's dive into the core principles that will help you get started on this journey. Understanding your energy consumption profile is the crucial first step in any energy efficiency journey. It's about figuring out where, when, and how energy is being used in your facility. Often, hidden opportunities lie within these patterns, like equipment running when it's not needed, systems working inefficiently, or processes consuming more energy than necessary. We'll explore some key concepts today. First, load profiling and demand analysis help us understand the overall energy load and when it peaks. Then, we look at strategies for managing peak versus off-peak consumption, which can save a lot of costs. Power factor correction is another important area. Improving this can reduce unnecessary energy losses. Identifying hotspots of energy waste allows us to target specific areas for improvement. We also consider seasonal and operational variations, since energy use can fluctuate throughout the year or with different operational states. Understanding your consumption profile is powerful because it enables targeted interventions. For example, in a textile mill we worked with, they found that 40% of their HVAC energy was used outside of production hours. A simple scheduling change in that case saved them 18 locks annually. By thoroughly understanding your energy consumption, you set the foundation for smarter, more effective energy-saving measures across your facility. Now, let's take a closer look at the energy audit process. First, we have the pre-audit planning phase. This is where we gather all the necessary facility data, analyze utility bills, understand the processes involved, and prepare the team for the upcoming assessment. It's essential to lay a solid foundation here to ensure the audit runs smoothly. Next is the site assessment. During this stage, we conduct a walkthrough inspection, create an equipment inventory, take measurements, and sometimes use thermal imaging to identify heat losses or inefficiencies. We also interview stakeholders to get insights into operational practices and potential problem areas. Following that, we move into data analysis. Here, we perform energy balance calculations, benchmark the facility's efficiency, identify opportunities for improvement, and estimate potential savings. This step transforms raw data into actionable insights. Finally, we compile our findings into a comprehensive report. This includes documenting what we discovered, prioritizing recommendations, conducting financial analyses, and outlining a clear roadmap for implementing improvements. Our training program supports this entire process with hands-on practice using real audit scenarios. You'll learn how to effectively use tools like energy meters, thermal cameras, light meters, and data loggers. We focus on teaching you how to spot opportunities that others might overlook, whether it's compressed air leaks, motor inefficiencies, or over-illuminated spaces. The goal is to equip you with the skills to identify and act on energy-saving opportunities confidently. Let's take a closer look at some essential audit tools and instrumentation that can really make a difference in our efficiency efforts. First up, we have the Power Quality Analyzer. This tool measures voltage, current, harmonics, and power factor, helping us identify electrical issues that can impact both efficiency and the lifespan of our equipment. It's like having a health check for our electrical system. Next is the thermal imaging camera. This device detects heat losses, insulation defects, electrical hotspots, and even mechanical problems before they lead to failures. Catching these issues early can save us significant time and money. Then we have the ultrasonic detector. This is great for locating compressed air leaks, steam leaks, and bearing issues. Often, these leaks and problems waste energy and cost thousands in unnecessary expenses. Identifying them early makes a big difference. Finally, we have the lux meter. Ensuring proper lighting levels is key for safety and efficiency. This tool helps us verify that lighting is adequate without being excessive, so we can save energy without compromising safety. All of these tools are vital for thorough inspections and ensuring our systems run smoothly and efficiently. They connect directly to our overall goal of optimizing performance and reducing waste. Now, let's dive into Module 2, High-Impact Technology Solutions. Here, we'll explore practical applications across some of the major energy-consuming systems. The goal is to understand how innovative technologies can make a real difference in efficiency and sustainability. We'll look at how these solutions are applied in real-world scenarios, highlighting their potential to transform the way we manage energy. This connects directly to our overall theme of leveraging advanced technology to achieve better energy performance. By the end of this section, you'll see how targeted technological interventions can lead to significant improvements across different systems. Let's talk about HVAC optimization, which really represents one of your biggest opportunities for energy savings. As many of you know, heating, ventilation, and air conditioning systems can account for around 40 to 50% of the total energy consumption in commercial buildings, and they also use a significant share in industrial facilities. The good news is, even small improvements in this area can lead to substantial savings over time. In the short term, there are some quick wins you can implement within 6 months, such as setting optimal temperature ranges, around 24 to 26 degrees Celsius for the Indian climate, regularly cleaning and maintaining filters, sealing air leaks in ductwork, and using occupancy-based controls and scheduling to avoid unnecessary cooling when spaces are unoccupied. Properly insulating chilled water pipes also plays a key role in reducing energy waste. Moving into medium-term improvements, things like installing variable frequency drives on air handling unit fans and pumps can optimize their operation. Upgrading to energy-efficient chillers with a high EER, above 3.5, is another effective step. Additionally, incorporating free cooling economizers and integrating your systems into a building management system allows for smarter, more responsive control. Let me share a quick case study. An IT park in Bangalore undertook a comprehensive HVAC optimization, adding VFDs, upgrading controls, and replacing chillers. The result? They achieved a 38% reduction in cooling energy consumption, which translated into savings of about 45 lakhs rupees annually, with a payback period of just over a year. Overall, focusing on HVAC optimization not only cuts costs, but also significantly improves your building's efficiency and sustainability. It's a critical part of the broader energy management strategy I hope you're all aiming for. Let's take a closer look at how lighting technology has evolved over the years and the new opportunities this creates. Starting in 2010, we were in the fluorescent era. These lights produced about 70 to 80 lumens per watt, but they required frequent replacements and had high maintenance costs. By 2015, we saw early adoption of LEDs. These offered around 100 to 120 lumens per watt, which was a significant improvement, and they lasted longer. However, the higher upfront cost limited widespread adoption at that time. Fast forward to 2020, and LED technology became mainstream. Now, we're talking about 130 to 150 lumens per watt, with prices dropping by about 80%. Plus, smart controls started to be integrated, making lighting systems more flexible and efficient. Most recently, in 2024, we're in the era of smart lighting. These systems deliver over 160 lumens per watt, are IoT-enabled, and incorporate advanced features like daylight harvesting and occupancy sensing. The key takeaway here is that LED technology has matured dramatically, offering much more than energy savings. Modern solutions improve light quality, reduce maintenance, and enable intelligent controls. For example, consider a manufacturing facility replacing 400 W metal halide fixtures with 150 W LED equivalents. This results in immediate energy savings of about 62.5%. And it's not just about retrofitting. Today's lighting systems can integrate with building management systems, automatically adjust based on daylight availability, respond to occupancy, and even provide valuable data on how spaces are used. This transforms lighting from simply being a cost center into a powerful operational intelligence tool. Typically, LEDs deliver around 65% energy savings and reduce maintenance needs by as much as 85%. So, as we see, the evolution of lighting technology is opening up new opportunities for efficiency, sustainability, and smarter building management. Let's talk about compressed air, which is often called the fourth utility. But in reality, it's one of the most costly and inefficient energy sources we use. Generating compressed air can cost 7 to 8 times more than the electricity it consumes. And here's the surprising part. Most systems waste between 30 to 50% of the air they produce. This waste happens due to leaks, improper usage, and poor system design. Now, one of the biggest culprits is leaks. For example, a tiny therm leak at 7 bar pressure can waste around rupee 45,000 each year in energy costs. That's a huge amount for something so small. The good news is, through systematic leak detection programs, we can typically find 20 to 30% savings opportunities. We'll teach you ultrasonic detection techniques, which are highly effective for locating and quantifying leaks quickly and accurately. Next, let's discuss pressure optimization. Reducing your system pressure by just 1 bar can save between 7 to 10% of energy. Many facilities run their systems at higher pressures than necessary, which leads to unnecessary energy consumption. We'll show you how to assess your actual requirements and adjust accordingly to save energy without sacrificing performance. Finally, we need to look at end-use efficiency. Often, compressed air is misused for cooling, cleaning, or other purposes that could be better served with fans or vacuum systems. By eliminating these inappropriate uses and properly right-sizing nozzles, we can achieve significant savings. All these strategies, detecting leaks, optimizing pressure, and improving end-use efficiency, are critical parts of reducing the hidden energy drain caused by compressed air. They help us cut costs, improve efficiency, and align with our overall goal of sustainable and cost-effective operations. Let's talk about motor systems and the role of variable frequency drives. As many of you know, electric motors are a major energy consumer in Indian industry, accounting for roughly 70% of industrial electricity use. This means that improving motor efficiency can lead to significant energy savings. Most critical are the components that rely heavily on motors: pumps, fans, compressors, and conveyors. These are everywhere in industrial processes, so focusing on their efficiency can have a big impact. One key opportunity is replacing older, standard motors with higher efficiency classes like IE3 or IE4. These motors use less energy for the same performance. Another important point is right-sizing motors. Oversized motors are common and often waste energy because they run at partial load, which isn't efficient. Implementing variable frequency drives, or VFDs, is another game changer. VFDs allow motors to operate at variable speeds, adjusting to actual demand. When loads vary, like in many applications, VFDs can dramatically reduce energy consumption. Because power consumption follows the Cube law, having the motor speed can reduce energy use to 1/8. That's a huge saving potential. In addition to these, improving mechanical efficiency by maintaining belts, couplings, and bearings further reduces energy waste. Proper maintenance and alignment are simple yet effective ways to keep motors running efficiently. Now, VFDs deserve special attention because of their ability to optimize energy use dynamically. When motor loads change, VFDs adapt the motor speed accordingly, leading to meaningful savings. For most applications, the energy savings from implementing VFDs can be substantial, sometimes over 30%. So, integrating these technologies and practices not only enhances efficiency, but also supports a broader move towards sustainable and cost-effective industrial operations. Renewable energy integration is a crucial part of our move towards sustainable development. In India, solar energy has become not just environmentally friendly, but also economically attractive. Thanks to abundant sunshine, decreasing costs of solar panels, and supportive policies from the government, rooftop solar installations now often have levelized costs lower than traditional grid electricity in many states. This creates a compelling opportunity, especially for industrial and commercial facilities, which typically have large roof spaces, an underutilized asset. These spaces can be transformed into sources of clean, cost-effective power that can serve the facility for over 25 years. Now, let's walk through the key steps involved in implementing rooftop solar. First, we have the feasibility assessment. This involves analyzing the roof's condition, evaluating structural integrity, studying shading patterns, and aligning the system with the facility's energy consumption patterns. This step ensures that the site is suitable and that the system will operate efficiently. Next is system design. Here, we determine the optimal capacity of the system, select the right inverters, plan the layout of the modules, and ensure proper grid interconnection. This phase is about customizing the system to maximize performance and integration with existing infrastructure. Then comes financial analysis. We develop models to evaluate capital expenditures and operational expenses, optimize incentives, and analyze net metering benefits. This helps in calculating the payback period, so the business understands the financial returns and timeline. Once everything is planned, we move to implementation. This stage involves selecting vendors, overseeing the installation process, commissioning the system, and ensuring it is synchronized with the grid. Proper execution is key to long-term success. After the system is operational, performance monitoring becomes essential. We track energy generation, schedule maintenance, and continuously optimize efficiency, ensuring the system performs at its best over time. To give you a sense of the economics, a typical 100 kW system might require an investment of around 40 to 45 lakhs rupees. It can generate approximately 150,000 kilowatt-hours annually, leading to savings of 12 to 15 lakhs rupees every year. The payback period is usually around 3 to 4 years, with an internal rate of return between 22 and 26%. Beyond the financials, there are additional benefits. Accelerated depreciation allows for significant tax incentives in the first year. It also protects against rising tariffs, enhances your company's sustainability profile, reduces dependency on the grid, and opens up potential revenue from carbon credits. Overall, integrating solar energy not only makes economic sense, but also aligns with our broader goals of sustainability and energy independence. It's a strategic move towards a cleaner, more resilient energy future. Now, let's move on to Module 3, Financial Analysis and Implementation. In this part, we'll focus on how to turn technical opportunities into approved projects. Essentially, this is about bridging the gap between identifying a promising opportunity and getting it approved for action. We'll explore the key steps involved in analyzing the financial aspects, such as cost-benefit analysis, return on investment, and risk assessment. These are critical to making a compelling case for project approval. Remember, the goal here is to communicate the value clearly and convincingly to stakeholders. This process ensures that innovative ideas don't just stay on paper, but are transformed into real, actionable projects that align with our strategic goals. It's an important step in turning technical potential into tangible results. Building the business case is a critical step in moving energy efficiency projects forward. While technical feasibility is necessary, it's not enough on its own. These projects need to compete for capital alongside other priorities like expanding production or replacing equipment. That's why having a strong financial case is essential. It helps justify the investment and prioritizes it within the organization. Let's start with the simple payback period. This is a straightforward calculation, investment cost divided by the annual savings. It's easy to understand and quick to compute, which makes it popular. Ideally, we aim for a payback of less than 3 years. This usually makes approval easier. However, keep in mind that it doesn't consider the time value of money or savings that occur after the payback period. Next, we have net present value, or NPV. This method discounts all future cash flows back to their present value and subtracts the initial investment. It takes into account the project's lifetime and the time value of money, providing a comprehensive view. A positive NPV indicates that the project creates value, making it a very useful metric for thorough analysis. Then there's the internal rate of return, or IRR. This is the discount rate at which the NPV equals 0. In other words, it shows the project's yield. Comparing the IRR to your company's cost of capital or hurdle rate helps determine if the project is worthwhile. For most energy projects, we're aiming for an IRR above 15% to ensure strong returns. Finally, we need to consider lifecycle cost analysis. This looks at the total cost of ownership over the equipment's entire life, including initial costs, energy consumption, maintenance, and disposal. It's especially useful when comparing alternatives like LED lighting versus fluorescence, because it reveals the true economics beyond just purchase price. During the training, we'll provide Excel templates and work through real examples. You'll learn how to factor in escalating energy tariffs, available incentives, tax benefits, and operational improvements that go beyond simple energy savings. This comprehensive approach will help you build a compelling, data-driven business case for your energy projects. Now, let's talk about some of the best practices for implementing these energy projects effectively. In the planning phase, it's crucial to secure executive sponsorship early on. This helps ensure we have the leadership support needed to drive the project forward. Next, forming a cross-functional implementation team brings together diverse expertise, which is key to addressing different aspects of the project. Developing a detailed project plan with clear milestones keeps us on track and allows us to measure progress along the way. We also want to identify and address potential barriers early, so we can develop strategies to overcome them before they become major issues. Planning for minimal operational disruption is important. Our goal is to improve efficiency without causing unnecessary downtime. Establishing measurement and verification protocols from the start ensures we can accurately track savings and performance, which ties directly into our overall success. Moving into the execution phase, conducting thorough vendor qualification and selection is vital. Choosing the right partners makes all the difference. Defining clear performance specifications helps set expectations and ensures everyone is aligned on goals. Implementing a staged approach, when possible, allows us to test and refine systems gradually, reducing risk. Monitoring installation quality closely ensures that the work meets our standards and performs as intended. Thoroughly commissioning the systems guarantees everything is functioning correctly before full operation begins. Training our operations staff on the new systems ensures they are prepared to manage and maintain the improvements effectively. Finally, in the sustaining results phase, establishing energy KPIs and dashboards makes ongoing performance transparent and manageable. Regular performance reviews help us stay on top of our goals and identify areas for further improvement. Implementing preventive maintenance programs keeps systems running optimally over the long term. Cultivating a culture of continuous improvement encourages everyone to look for ways to enhance performance further. Celebrating and communicating wins keeps morale high and demonstrates the value of our efforts. Planning the next phase of improvements ensures this is an ongoing journey, not a one-time effort. And a critical success factor across all these phases is measurement and verification. Remember, you can't manage what you don't measure. Robust monitoring is essential. It verifies savings, helps us identify issues early, and maintains performance over time. Now, let's take a look at some common implementation challenges that we often encounter. First, budget constraints can really pose a hurdle. The challenge here is that limited capital availability often competes with other priorities within the organization. To address this, we can start with no or low-cost measures, which are often quick wins. Using ESCO financing is another effective approach, as it allows for upfront investments to be paid back through the energy savings. Leveraging incentives from programs like PAT schemes can also help. Additionally, phasing the implementation over time makes it more manageable, and quantifying non-energy benefits, such as reduced maintenance costs or productivity improvements, can help justify the investment. Next, operational resistance is quite common. Staff might resist change because they fear it could impact production, or they're simply comfortable with how things are. To overcome this, early engagement with stakeholders is key. Demonstrating pilot projects can build confidence, and providing thorough training and transparent communication helps address concerns. Showing quick wins can motivate the team, and involving operations staff in planning ensures their insights and buy-in. Technical complexity is another challenge. Integrating new systems with existing infrastructure can be tricky, especially when dealing with diverse equipment and ensuring compatibility. The best approach here is to bring in qualified consultants who understand the technical details. Conducting thorough due diligence helps identify potential issues early. It's also wise to specify clear performance guarantees, build in contingency plans, and allocate sufficient time for testing and commissioning to ensure everything works smoothly. Finally, performance persistence can be an issue. Sometimes, the initial savings we achieve tend to decline over time. This can happen due to maintenance lapses, changes in staff behavior, or system drift. To maintain performance, continuous monitoring systems are essential. Regular audits and well-defined maintenance procedures help keep systems running optimally. Establishing energy champions within the organization can foster ongoing awareness and accountability. Performance-based contracts and management review processes also ensure that sustained savings are a priority. By understanding and proactively addressing these challenges, we can significantly improve the success and long-term impact of our energy efficiency projects. Your energy efficiency journey starts today. Remember, energy efficiency isn't just a one-time project. It's a continuous journey of ongoing improvement. The skills and knowledge you gain from this training will stay with you throughout your career, especially as energy management becomes even more critical to your business's success. Let's talk about some practical next steps. First, apply what you've learned by conducting a walkthrough audit of your facility within the next month. Identify your top 5 opportunities for improvement and try to quantify the potential savings these changes could bring. Second, build your team. Energy management isn't a solo effort. It requires collaboration. Engage key stakeholders from maintenance, operations, procurement, and finance to support and drive your efficiency initiatives forward. Third, start small but think big. Focus on quick wins that can build momentum and establish credibility. Use those early successes to gain support for larger, more impactful projects down the line. Fourth, measure and share your results. Keep track of your progress rigorously and communicate your successes widely. The visibility of your achievements will foster accountability and help scale your efforts across your organization. And finally, never stop improving. Technology advances, tariffs change, and regulations tighten, so commit to continuous learning and enhancement. This mindset will help you sustain results over the long term. If you're ready to take the next step, remember that Elion Technologies is here to support you. We offer comprehensive energy audits, customized training, implementation support, and ongoing optimization services. Visit our website at www.eliontechnologies.com, email us at energy@eliontechnologies.com, or call us at +91 8,852,080,5208 or 9,013,890,526. Together, we can build a more sustainable and profitable future for Indian industry.